Section 6.5, Basic Trig Identities. We're going to develop basic trig identities. An identity is an equation that is true for all values of the variables for which every term of the equation is defined. For example, a plus b quantity squared is equal to a squared plus 2ab plus b squared. This is an identity because it is true for all possible values of a and for b, just like the sum of square or the sum of two cubes or the difference of squares. Those would also be identities. So we have the quotient identities, which we've kind of already talked about. Tangent of t is sine over cosine. Cotangent is cosine over sine. And yes, you need to know that the name for that is the quotient identities. Your reciprocal identities are also written here. So the sine of t is 1 over the cosecant of t. Cosine of t is 1 over the secant of t. And tangent is 1 over the cotangent, etc. So make sure that you write those down. And you need to know that the name for them is the reciprocal identities. The next part that we are going to talk about are the Pythagorean identities. If you remember from our unit circle, if I were to draw a triangle, then I know the distance here is x and the distance here is y. And the equation for the circle is x squared plus y squared equals your radius squared, which in this case is just 1. From this, we can get our Pythagorean identity, and that's why it's called the Pythagorean identity, because it's using the Pythagorean theorem to find the x squared and y squared equals the 1. So remember we said that cosine was equal to the x value, sine is equal to the y value, so because of that we can get the cosine squared x plus the sine squared of x is equal to 1. So this right here is an identity, which is also written here. Usually it's written as sine squared x plus cosine squared x equals 1. It doesn't really matter how you write it, but you'll see a lot of people usually write it like this. Now, from that, we can derive two other identities. So if I know cosine squared x plus sine squared x is equal to 1, so I'm going to write that over here. Or actually, you know what, let me write the other way. So let's do sine squared plus cosine squared x equals 1. Well, the other two identities I can get by dividing out sine or cosine. So if I divide this by sine squared x, and I divide each term by sine squared x, well, I can use my identities to simplify this. Well, sine squared x over sine squared x would just be 1, plus cosine squared over sine squared x. Well, cosine over sine we know is really equal to cotangent, so this would be cotangent squared x equals 1 over sine squared x would be a reciprocal identity. So the reciprocal identity for this would be 1 over sine, which becomes cosecant squared of x. So this is another Pythagorean identity right here. Now I can get another Pythagorean identity if instead of dividing by the sine squared, let's say we divide by cosine squared x. So if I divide by cosine squared x, the other Pythagorean identity I can get, sine squared over cosine squared, would be tangent squared x plus cosine squared x over cosine squared x is 1 equals 1 over cosine squared x would be equal to the secant squared x. This is the other Pythagorean identity. So there are 3 of those that you need to know. Now, for these 3 that we have, these are the main identities. So like I said, make sure that you know each of these that we have right here. But from each of these 3 identities that we have, we can also come up with 2 more for each of them by solving. So for this first one that I have, the first identity, we can solve for sine by subtracting cosine to the other side. So another identity we use would be sine squared t is equal to, and it doesn't matter if you use t or x, 1 minus cosine squared t. Another one we can get is if we solve for cosine by subtracting sine squared to the other side. So cosine squared t is equal to 1 minus the sine squared t. And those you also need to know as well, but they're not really called Pythagorean identities, but we can derive them from our Pythagorean identities. And we often use these values when we're doing our identities to use to substitute and to solve trig identities. So for the next one, we can do the same thing. If I solve for 1, I know that the cosecant squared t minus cotangent squared t is going to be equal to 1 because I just subtracted this to the other side. And then I could also say that the cotangent squared t is equal to cosecant squared t minus 1. And notice that cotangent and cosecant are together, which makes sense because remember, cotangent in your denominator, you have sine, and for cosecant, it's 1 over sine. And remember, your asymptotes, if you graph them, are in the same places, so that's why cotangent and cosecants go nicely together. The last one then, we have tangents and secants, which are nice because remember, for your denominator here, you have cosine in the denominator, so your asymptotes, if you were to graph it, are in the same place. Unless you have transformations, of course. And then, so for this one, if I solve for tangent squared t is equal to secant squared t minus 1. And then I can also solve for 1 by doing secant squared t minus the tangent squared t is equal to 1. So make sure again that you have all these memorized. You need to know each of these. So these are the 3 Pythagorean identities where we get 2 different ones for each. And again, we'll be using them a lot. And you need to have all of these memorized, the quotient identities, reciprocal identities, because those are often used as well. So I made it look a little nicer right here. So these are the Pythagorean identities, and again, you can get 6 more identities out of that. Periodicity identities are just identities where you're adding plus or minus 2 pi to your equation. So if I add coterminal angles to my angle sine of t, that's just going to give me the sine of t, or same thing for cosine and tangent. And identities involving pi minus t are right here. You don't really need to have these memorized. We don't really use them too often, so it's okay if you don't really know those. But the other one that you also need to have memorized is negative angle identities. So the sine of negative t is equal to negative sine of t, cosine negative t is equal to cosine t, and tangent negative t is equal to negative tangent t. It's really important that you have these memorized. If you don't start memorizing them now, you're going to have a really hard time doing these problems. Note that sine t cubed is not the same as sine t with a cubed on the outside, but we can rewrite the sine t cubed is the same thing as sine cubed t, which you'll need to know when we are doing these in our graphing calculator to check, because you can't write it like this in the calculator, you have to write it like this. But remember that that is not the same thing as the sine of the angle cubed. So don't forget that. So let's do some practice. When simplifying these, which is what we're going to be doing, we're going to combine like term using our algebra. A lot of these are just using algebra. And when you're doing that, remember you don't want to have parentheses when you simplify things, and you want to try to get your answers into one term. Usually try to get into sine or cosine or tangent or into 1. Now for the first one, if we're simplifying this, that means that we want to use those identities that we've learned. So in order to do that, I know that cosine doesn't really change into anything except for 1 over the secant, and that's not going to help me out very much. So what I could do to simplify this is change my tangent using my quotient identity. Tangent is the sine of t over the cosine of t, and that's being multiplied by the cosine of t. And if you want to put that over 1 to help you out, that's fine. Just show you that then you can cross out, since it's multiplied, your cosine t's. So really this would be equal to the sine of t. So that would be my simplified answer, because now instead of having tangent times cosine, we have the sine of t. And this is helpful, and the reason we do this is because later on when you get into calculus, it's really helpful to know how to change something to make the problem a little bit easier. For the next one, it says, given sine t equals 0.28 and cosine t equals 0.96, we want to find cosecant and secant. So remember that the cosecant of t is really equal to 1 over the sine of t. So in this case, 1 over 0.28, and of course we don't like to have decimals in our problem, so this would really be 25 over 7. And then for the secant of t, that is the same thing as 1 over the cosine of t, which would be equal to 1 over 0.96, which is equal to, when we write this into fraction form, 25 over 24. So using the reciprocal identities helps us solve for other parts, which we've talked about before. For number 3, we are simplifying this. So if I want to simplify this, we have tangent squared times cosine squared t plus cosine squared t. Now that means I want to try to get this into one term if I possibly can. Well, tangent I know is sine over cosine, so I'm going to start with that. So sine squared t, and we have to use squared because this is squared here, over cosine squared t times cosine squared t plus cosine squared t. Remember, this is really over 1, so that cancels out to leave me with sine squared t plus cosine squared t. Can we get sine squared t plus cosine squared t, simplify that any further into one term? Yes, we can. We can get this into one term because this is a Pythagorean identity. Sine squared plus cosine squared is equal to 1. So that would be the solution there. So why don't you guys see if you can pause it and do number 4 on your own, and then I'll pause it and we'll do it together. So for number 4, same thing, except for now I have cotangent times sine plus sine. So this would be cosine squared t over sine squared t. That's just my quotient identity, times the sine squared t, and that's really over 1, plus the sine squared t. This cancels out to leave me with cosine squared t over 1. And I don't really even need that 1 right there, so I'll just go ahead and erase it. And then we have plus sine squared t. And again, right here, this is my Pythagorean identity, so that's equal to a value of 1. And again, when you're simplifying these, you're trying to see if you can get it into one term using your identities that you have memorized. Now for the next one, it says find the exact value of sine 13 pi over 6. So that would be using our periodicity identities, because I know that this is coterminal with one of my angles on my unit circle. So I'm trying to figure out if it's 13 pi over 6, that means I went around my circle more than once. So then for that, I would have to figure out 13 pi over 6. Well, if I subtract 2 pi from that, I need a common denominator. So common would be 6. So that would become 12 over 6. When I subtract, I get pi over 6. So then I know that the sine of 13 pi over 6 is the same thing as the sine of pi over 6 using my periodicity identity. Because pi over 6 plus 2 pi gives me 13 pi over 6. And then I just use my unit circle. Okay, so my unit circle, pi over 6, we're in the first quadrant. So in the first quadrant, I have to figure out what the sine is. Remember, the sine is the y value. So in this case, this would be equal to a value of 1/2. And again, that's just using your unit circle. And the very last part. So the very last part says use the Pythagorean identities to find the sine of t for the given value of cosine t. Make sure the sine is in the correct make sure the sine is correct for the given quadrant that you have. So right now it says the cosine of t is equal to -3 over root 10, and it's in the quadrants pi over 2, in between pi over 2 and pi. So first you have to think, what quadrant's in between pi over 2 and pi? Well, I know that's going to be quadrant 3, and how do I know that? From my unit circle, because remember this is pi over 2, and this is pi right here. This is 3 pi over 2, and this was 0 and 2 pi. And then if I want to solve this, I can use my Pythagorean identities, or I can go ahead and make a triangle. So I'm going to show you two ways to this. If I make a triangle, cosine is adjacent over hypotenuse, so this would be -3, and this would be root 10. And then I could use my Pythagorean theorem in order to figure out what the other length would be. So if I do that, I know it's actually going to be a length of 1, but we'll come back to that. So if I want to use my Pythagorean identities to do this, I know that sine squared t plus cosine squared t is equal to 1. So if I know what the cosine is, then I can solve for sine, because sine squared t is equal to 1 minus the cosine squared of t. All I did was subtract the cosine over. So sine squared t is equal to 1 minus, in this case, negative root, or -3, oops, over root 10. And of course, that is squared because it's cosine squared. And then if I keep going, I get sine squared t equals, and this would be 1 minus -3 squared would be 9, and root 10 squared would be 10. Now I need a common denominator to get these together, so sine squared t would be equal to, what's common between these two would be 10 over 10 if that's just 1. So this gives me 1 over 10. Since this is sine squared, to get sine by itself, just like if it was x squared to solve, you would take the square root of both sides and plus or minus your answer. So you get the sine of t is equal to plus or minus the square root of 1 over 10, which becomes plus or minus the square root of 1 is just 1 over root 10. And then remember, if we have to look at our quadrant to tell what the sign is. So remember, all students take calculus. So in the third quadrant, sine is positive, so I don't need the plus or minus. Really, sine would be equal to 1 over root 10, which we don't leave it like that. This would become root 10 over 10. So that's for the sine. I'm not done though. Oh yeah, I guess I am, because I already found the cosine and the sine, so that would be my sine. I could also use my other Pythagorean identities to solve for cosecant or secant or tangent, and I now know again that this value right here, if I do the square root of 10 squared minus 3 squared, it would give me my value here, which we'll call y. So this would be 10 minus 9, which is where I got that 1. So I could have did what I did. Instead of using my Pythagorean identities, I can still use my triangle to solve. And then from there, I could have gotten the fact that this is the angle that I'm using for t. Sine is opposite over hypotenuse, so 1 over root 10, which gives me root 10 over root 10. The reason I use the Pythagorean identities is because it said in the question to use the Pythagorean identities, but it's easy to make a triangle and then check your answer. So this is what we're going to be doing in class. So like I said, you want to start right now to make some flashcards and put the identities on those flashcards, because you really need to have them memorized. When you're doing your homework, you're going to want to not use your identities, because you're going to want to have them memorized, because you won't be able to use them on your test.